6 years ago, I did a video on how the seas would work on flat Earth. And after reading some of the comments, I figured I better clear up a few questions. Number one was electrocution, okay? And secondly, I wanted to compare it to if you were to do a Google search on sea currents on a globe. And all the charts are pretty much the same. I even looked at prevailing winds. The winds are pretty much the same as the ocean currents, pretty much, close enough anyway, so I'm not going to deal with them. But it's pretty standard. On the bottom here, or in the South Pole, the ice ring, everything moves counterclockwise. Okay? The equator is pretty much clockwise, and again, in the southern hemisphere, everything is counterclockwise, and clockwise in the northern hemisphere, and they call that the Coriolis Effect. So I'm going to plug this thing in, put some salt water in there, and we'll see what it does. Alright, hopefully you guys can see the ocean current moving. Just add a little more pepper, just so you can see it better. Alright, and much like a Google search on current direction, you have everything on the outer ring is moving east. Everything around the equator is generally moving west. In the southern hemisphere, you got a counterclockwise rotation. You got some over here in the Pacific, also over here in the Indian Ocean. And in the northern hemisphere, you got a clockwise rotation. Okay, so, and once again, I'm not getting electrocuted. See? It's just, I just moved my equator. All right, so I just demonstrated the Coriolis effect also with my little model here. So if I'm totally off base, why does it seem to match what you'd find on a Google search as far as the direction of the current goes? There has to be a little bit something to it. I can demonstrate this on my model, and of course I cannot demonstrate it on a ball.